Hi, welcome to a quick recording on the, what is it called? UELVEs MBC, Embassy, the Mythbusters car. We're now doing this under the Open Source Ecology website, so I'll put the link in the page. This video focusing on the door frame, the door sill. I just wanted to go over that. I could really use some help in with some actual programming on the allocation and the location of the nodes. In particular, what we've got here is I've taken out some of the parts so they're not visible and won't interfere with the what we're seeing here. Just go in there. Alright, so each of this is the door sill and it's in green, and the parts are located, and I've had to manually locate the node point, which that's the green one, relative to this one, which is the door sill and windscreen point. At the angle from which the green point is located, the angle and distance at which they're placed, I've had to manually do every single one of them, followed by, it's a real pain, see the green pipe, I've had to manually place that green pipe at a distance from the pink one, and then manually place that one at a distance from that one, etc, etc. And it is a royal, as you can imagine, it is a royal pain in the arse. Any change to any of those, any of these pipes here, you know, the yellow, the brown, etc, will need to have these, the green ones, completely redone as well. Relative distance, you can already probably see there is a slight from there, this particular pipe here, actually that distance is not so bad. The help that I could do with, if I go, excuse me, is basically a function which defines, which, given the points that you want to be able to set distance, the pipes to be a set distance away from, is it's given given that distance, it actually computes a new set of nodes. The circular, the spherical pieces, the nodes, computes that and gives you the new nodes, and automatically offsets the pipes so that there are the second set of pipes, these compared, that's the first set and that's the second set, computes the distance, it computes the locations given the distance away from those pipes. So it's quite an interesting little 3D computation issue. And the way that this this node and pipe system works is that I've created an auto joint system where it will work out the location, the most convenient location that the joint should be on, and it's basically it's on the Z direction. It can be either be upright, you know, 0 degrees, a 45 degree angle, a 90 degree, a 135, a 180, a 2 something, whatever, 270, and things. So it's basically 8 locations around the clock, but that is done on all 3 axes, so on X and Y and Z, and you end up with these sort of, if you look at, let's find, oh yes, this one actually, here, that one, you can see there's some nice arrangements of 45 degrees, so this pipe here goes straight that one there goes out at 45 degrees, and that one goes at 90 degrees. In the Z plane, and the reason it's all in this, all at that angle in the Z plane, is because all three are on that on that or say Z axis. Sorry, they're all on the Z axis because they're all in the Z plane. If one of those have been angled more than a certain angle down, for example, this one here, this pipe going down, it will drop so that this would come out at a different. Oh, you can see that one. That one has automatically been calculated as needing to come out from that angle. So, but this turns out not to be enough in some circumstances, particularly for this complex. I'm going back to the green again, hitting here. So what I've had to do is not only to compute, manually set the offset point from this sphere by taking this sphere here and then creating a small vector which is rotated by an angle to give you a set distance away from that. That angle I've had to manually refine, but then the angle between here and this joint thing, the plus position where it lands on that node, on this node here, has also had to be manually set so that this distance remains, and then at the other end as well, so that let's bring it out a little bit, so that by the time the pipe gets to here, that distance is equal, and you can see that here in between these it's not in between those two pipes. Hang on, excuse me one moment. In between these two pipes here, this one and that one, that distance is not equal, so that's another one that I've got to go and investigate and manually change this the angle that this meets on here. This is a pain, because now having done this for the door frame, we now also have to do it for the door, which is, which you can see is on there. Let me just bring that angle out a bit to show you put the door at a 20-degree angle. There we go. So you can actually see it's got an openable door. Wow. Now, what I've done here with the door is to simplify this horrible mathematical task slightly, is that each of the red points is offset by a set fixed distance in this direction from the green door frame. So if I do that and then I move down to the next point, you can't see the other point on the door frame because it's hidden. Whoops, hidden behind it, like that. Okay, so and in that way, the goal is that this red pipe would be a fixed distance from the purple pipe. And likewise, when the angles that it comes off from, etc., etc., are all manually calculated, this red pipe here should also be a set distance from that green pipe and a set distance from that purple pipe, which if you look all the way down here at the moment, clearly it's not. So this is something I could really do with some help with, some mathematical formula and can computations where you just have to specify these nodes, specify the distance between these pipes that you want them to be, and it will just be calculated and it'll be happy. I don't want to have to mess about doing this manually, because you have one single change on any of these points. If I move that, this say that node has to go over for whatever reason, for there's some sort of because it's the windscreen, because there has to be some change in the viewing angle. When the person is sitting inside the car, there's a certain angle, the door frame has to be a certain thing, blah blah blah, etc, etc, visibility, filters and mirrors, etc, etc. You make one change to that one node, and the every single one of those manually calculated angles and distances in the pipes is screwed and requires redoing again, and we don't need the hassle. So this is a parametric system. It's written in Python, so there is absolutely no reason why that shouldn't be done. This isn't FreeCAD, it's actual Python, so anybody who's got some 3D graphics experience could very easily help out here. So, thank you very much.